All right, hi, it's Mr. Leong, and this is topic 1.5, representing a quantitative variable with graphs. Now, before we start talking about the graphs, we want to first talk about the different types of quantitative variables. There's two different types that we're going to discuss, and then we'll go over 4 different graphs for quantitative data. All right, so the two types of quantitative variables we have are discrete and continuous. Discrete variable only takes a fixed set of values, and there's going to be gaps in between them. And this is usually the result of counting something. So an example of a discrete variable would be the number of students in a class. So if we think about the values that this variable could take, maybe there's 25 students in a class, or 26 or 27, right? So we get these results by just counting the students, and there's going to naturally be gaps between the values because you can't have a half a student or a quarter of a student or any fraction of a student, right? Students only come in whole numbers. Okay, so if we were to look at the values of a discrete variable on a number line, it would just be a bunch of points with gaps between. Okay. A continuous variable can take any value in an interval on the number line. And these usually result from measuring something. So an example of this would be the height of a child. Okay. So maybe we measure a child and that child's 107 centimeters tall, or maybe they're 108 centimeters tall. Can they be measured at something in between those two values? Of course, right? They could be 107.5 centimeters. Could they be measured at a value in between, say 107.5 and 108? Well, sure, right? If we have an instrument precise enough, right, we can measure height to, I don't know, 10 decimal places if we really wanted to, right? So the thing about a continuous variable is that any two values you have, it's always possible to measure a value in between those, right? And so what ends up happening is, you can just get any value on the number line, right? So we get a continuous looking graph like that. Okay. So discrete is the result of counting, and there's going to be gaps between values. Continuous is measuring, and there's really an infinite number of values that you can get depending on the precision of your instrument. Okay, so here's a list of variables, and we're just going to read through them and determine which are discrete, the result of counting, and which are continuous, the result of measuring. Okay. So distance from your home to school, right? So normally we would measure this in miles or kilometers. The units here don't matter, but the idea is that we're going to measure it. Okay? So that's going to be continuous. Okay. Number of siblings, right? We would just count. I've got 0, 1, 2, 3. Right? Usually discrete variables take on integer values only, right? Could take decimal values like shoe size, right? I wear a 5, a 5.5, 6, 6.5. But normally, if it's discrete, it's generally going to be an integer value. How many books you've read in the past month? So you would just count how many that is. So it's discrete. How long it took to complete an online survey. So how long is a measure of time? So it's a measurement, right? 5 minutes, 6 minutes, 5.5, 5.25, 5.12863 minutes, right? So you can measure that. It's continuous. Okay. All right, so now for the meat of this lesson, which is how do we graph quantitative data? And we're going to go through 4 graphs, and these go from kind of simplest to more complex. So we've got a dot plot, stem and leaf plot, histogram, and a cumulative graph. Okay. So I'm going to switch over to my document camera. And then we're going to look at a hypothetical data set. All right, there it goes. All right, so let's say we have the following test scores. So 12 was the lowest test score and 48 was the highest test score. And we want to represent this data with first a dot plot. Okay. So for our dot plot, we're going to start with a number line. And then we're going to want to put some markings on it, and I might want to mark, every 5 or every 10, something that's kind of easy and natural So let's go 10, 15, 20, 25, 30, 35, 40, 45, and 50. Okay. 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. And then I also want to put the name of the variable below this number line. So this is going to display the test scores. Okay. All right, now for each score on the list, I'm just going to put a dot at that specific value on the number line. And if I have multiple scores of the same value, then I'll just stack the dots. Okay, so we have a 12, an 18, 22, 25, 29, 31, 32, 35, 36, 37, 38, 38, 38. Now I realized there was two 32s. Okay, 40, 40, 41, 42, 43, 44, 45, 45, and 48. Okay. All right, so like I said, dot plot is the simplest graph. Now, normally you would reserve this for small data sets. You wouldn't want to make a dot plot by hand if you had like hundreds of values in your data set. All right, so the second type of graph that we'll make is a stem and leaf plot. Okay. So for a stem and leaf plot, what we're going to do is we're going to separate each value into its 2 digits. Okay. So I have scores in the 10s, 20s, 30s, and 40s. Okay. So what we'll do is we'll draw a vertical line. Okay. And then we're going to use a row to record all the values in the 10s or teens. Another row to record data in the 20s, 30s, and 40s. Okay. So we've already recorded the digit in the tens place of each test score. Now I just have to record the digit that's in the ones place. So for the first score of 12, right, I would just record a 2 in the tens row. And then for 18, I would just record the last digit 8 again in the tens or the teens row. Okay, 22, 25, 29, okay, 31, 32, 32, 35, 36, 37, 37, 38, 38, 38, 38. Okay. And, I think going back now, I think I forgot to do the 2 37s. 37. Forgot to do that. And there was 1, 2, 3, 4 38s. All right, so let me fix my dot plot a little bit. Okay. All right. 40, 40, 41, 42, 43, 44, 45, 45, and 48. Okay. All right, so the digit in the tens place gets recorded just once, and then all you need to do then is record the digit in the ones place in each row. Okay. All right, we need to put a label and also a key. So again, these are test scores. Okay. And then let's just kind of choose, I'll just choose the first stem and the first leaf. Right? So 1 next to a 2 equals 12 points. All right, remember, these are test scores, so we're going to assume the units are points. All right. Now, something else we can do with a stem and leaf plot, if we see that there's a lot of data kind of in one row, is we can split the stem, so we can do highs and lows. Okay, so what that would look like. Okay, so we'll have low teens, high teens, low 20s, high 20s, low 30s, high 30s, low 40s, and high 40s. Okay, so instead of one row for all the teen values, we're gonna have 2 rows. Okay, so what constitutes a high teen versus a low teen? Well, it's the same concept that you learned when you learned how to round numbers. So If it ends in a 0 through 4, it'll be low, and if it ends in a 5 through 9, it'll be high. Okay. So 12 would be considered low. So I'd put it in the first row. 18 would be considered high teens, so it would go in the next row. 22 is low 20s. 25 would be considered high 20s. Same with 29. Okay. 31, 32, 32. Okay, those are all my low 30s. And then 35, 36, 37, 37, 38, 38, 38, 38. Those are all my high 30s. Okay. 40, 40, 41, 42, 43, 44, and then 45 and 48 are my only high 40 test scores. Okay. Just like with the other stem and leaf plot, we need to include a title or a label, test scores, and then also a key. And I'll just use the first stem and leaf right here. Okay, so a 1 next to a 2 is 12 points. All right. So now that we have done the dot plot and the stem and leaf plots, we're going to do a histogram. Okay. So what a histogram does is it's going to group values that are close together. Okay, and how we group them is really up to us. We can group into sets of 10, sets of 5, sets of 2. It's just kind of whatever seems natural. So in this case, I think I'll group test scores into intervals of 5. Okay, so first let's make a table. All right. Let me grab a second sheet. Okay. I want to be able to see the data again. All right, so let's create intervals. And then we'll also do like a tally as well. Okay, so let's go 10 to less than 15. We can go 15 to just less than 20, 20 to 25, 25 to less than 30, 32 less than 35, 35 to less than 40, 40 to less than 45, and then 45 to just less than 50. All right, so you might be wondering, why don't I just say 10 to 15, 15 to 20, 20 to 25? Why am I specifying less than 15? Okay, well, if I just did 10 to 15 and 15 to 20, then what would I do? I'd have a dilemma if I had a value of exactly 15. Would it go in the first interval or would it go in the second interval, right? So this less than sign indicates that this interval ends just before 15, right? So 14.99999, if I had decimal values, would go in this interval, and then 15.0 would go into the next interval. Okay, just so that there's no vagueness about how we create this table. Okay, so how many test scores are exactly 10 to less than 15? Well, it would just be that one. Okay, let's just circle it. Okay, how many test scores are from 15 to less than 20? Just that one. 20 to less than 25? Just one. 25 to less than 30? That would be 2. 30 to less than 35? That would be 3. 35 to less than 40? Okay, a lot. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 40 but less than 45. 1, 2, 3, 4, 5, 6. And then 45 but less than 50. That would be 3. All right. let's rename this. I was going to do tally marks, but it just ended up being easy to count since we circled the groups of numbers that were close to one another. So we'll just write count. Another word for count is frequency. All right, so next, I guess this is enough. We can graph it now. Well, let me see. Let's just do percentage as well. All right, maybe I want to do a relative frequency graph. Okay. All right, so to get to percentages, I have to divide each count by the total. I first need to know what that total is. 3, 9, 17, 20, 2, 3, 4, 25. Okay, so the total is 25. All right, so now we'll just divide each of those counts by 25. 1 divided by 25, that's 4%. Let's do proportion, sorry. Okay, 0.04, 0.04, 0.04. That'll be 0.08. That'll be 0.12. 8 divided by 25 is 0.32. 6 divided by 25 is 0.24. 3 divided by 25 is 0.12, and that should add up to exactly 1. All right, so now what we're going to do is we're going to put these intervals on the horizontal axis. Okay, and then we need to mark this, of course. So this would be, let's move over. 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, and we're going to label this test scores. Okay. And then on our vertical axis, we're going to record the proportion or percentage, however you want to display it. Okay, so we'll start. Let's see, the highest one is 32. So let's see, 0, let's go 5, 10, 15, 20, 25, 30, 35. That's as far as I need to go. 0, 0.10, 0.20, 0.30. All right. So we've got test scores on the horizontal axis and the proportion, or you can write it as a percentage on the vertical axis. And now we're just going to draw bars where the height of the bar is going to match up with the proportion. Okay. So there were 4% of the class scored between 10 to less than 15. So 4%. Okay. 4% of the class scored between 15 and 20. 4% of the class scored between 20 to less than 25. 8% of the class scored between 25 to 30. 12% of the class between 30 to 35. 32% of the class between 35 and less than 40. 24% of the class between 40 to 45, and then 12% of the class 45 but less than 50. All right, so that's our histogram. Now the final graph that we're going to make is called a cumulative graph. And then what it's going to do, it's going to take these proportions here, but kind of total it up as we go. Okay, so if we just start adding things, so the first row is, let's add a header here. Cumulative. All right, so we've got 4%. Add that to the next row. So now we're at 8%. add that to the next row. Now we're at 12%, add that to the next row, 20, keep adding, 32, keep adding, 64, 64 plus 24 is 88, 88 plus 12 is, 100%. Okay, so we're accumulating the proportions as we go down the table. All right, so now what we're going to do is we're going to take these cumulative percentages and graph those against the intervals or the test scores. Zoom out a little bit there. All right, so we need 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, and then over here, we need to go from 0 to 100%. So let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, perfect. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so I'll just do 0, 50, and 100. And I'm just going to label this cumulative percentage. All right, so we're going to start at 0%. Right, nobody in the class scored less than 10 points. Okay, but then we're going to jump up to 4%. Right, because we know 4% of the class scored under 15 points. And then we're going to go up to 8, because we know a total of 8% of the class scored under 20 points. And then we go to 12, and then 20, and then 32. And then 64, and then 88, and then finally 100. All right. So as we increase the score that we're looking at from 10 points to 50 points, we're recording what percent of the class scored under that score, right? So let me just highlight one particular part here. So like, let's take a look at this point here, right? So this point says about 60-something% of the class, I think it was 64%, 64% of the class scored under 40 points, okay, less than 40 points. So that's the way that you would read a cumulative graph. All right, so thanks so much for watching. So we covered the cumulative graph, the histogram, stem and leaf plot, split stems, and then the dot plot. Something else I almost forgot to mention is how you can create some of these graphs online. So let me switch over to web browser. Okay. Yep. All right. So this is the slaplet.com website. So let's say that we had input all those test scores in here, and then the software could actually do many of these graphs. So here's the dot plot. Okay. And then we can go look at the stem plot. Okay, so notice we've got 10s, 20s, 30s, 40s, and then the last digit is recorded here. There's a key. We can do split stems. So it'll split it into two groups, so highs and lows. That's how we did it by hand. You can also split it into groups of 5. So let's look at the 20s, right? So for scores in the 20s, this would be like 20, 21, 22, 23, 24, 25, 26, 27, and then 28, 29 would go in the last row. That might be a little excessive. It depends on your data set. Okay. And then we can do the histogram. And this is how we did it on paper. So our intervals were every 5, 10 to 15, 15 to 20, 20 to 25. You can display the frequency or count, or you could display the relative frequency percentage. You can change the widths, right? So maybe I want to group scores by tens, right? So let's put 10 here. Enter interval width 10. Looked like it did something, but there. I guess I have to hold it down. All right. So then we've got, 5 to 15, 15 to 25, and so on. It might not seem natural to start at 5. Maybe we might want to start at 10. Oops. Okay. So now we've got scores from 10 to 20. And we can see that that was, if we hover, about 8% of the class. Okay. Scores between 20 and 30, 12% of the class. 30 to 40 is 44% of the class. And 40 to 50 is 36% of the class. Right? So you can make a lot more like tweaks and adjustments when you use software. Whereas if you do it by hand, it's like you got to pick one interval width and then just go with it.